Welcome to 4 Questions with an Engineer, a podcast about bearings and motion control. Today we are speaking with Nick Jerinic, a robotics engineer for CCTY. Nick, thanks for joining us today. What are the trends that you are seeing in humanoid robotics?
I like to kind of divide this into 2 sections, one in bipedal motion and then the second in quadruped motion. And quadruped motion is mainly what you'll see in robots like Boston Dynamics Spot, Unitree's 4-legged robot, and then obviously the bipedal motion is for the companies like Electronic Agility and robots that walk on 2 legs. Mainly what you'll see in them right now is things like impact resistance, motion control, torque and clearance, and then of course safety and efficiency for warehouse implementation, because that's mainly where these robots are going to be going.
Humanoids depend on fluid motion. What bearings are mainly used in this type of robot?
Mainly would be a self-lubricating bearing, and this is because you don't want to have to maintenance the components on a robot. You're also going to want to have one that has a high cycle life, and of course you're going to want to have 0 torque and clearance, but this is physically impossible. But trying to get to a number as close to 0 is what you're going to want to use. And characteristics like these really complement fluid motion control in humanoids, and unfortunately you won't be able to get this with an off-the-shelf product. If you're making something that's super precise and super specific, you're not going to find it in a commodity product that you can find everywhere. There is a difference between off-the-shelf bearings, off-the-shelf products, compared to something that's specifically designed for your application. All of it really has to do with torque and clearance. Those are the 2 things that are probably the most important characteristics when it comes to developing a bearing, because if you have a lot of clearance, then obviously you'll have a lot less torque, which is good. But if you have a lot of clearance, then that affects the motion, precision, everything else of it. On the other hand, if you have very little clearance, then that helps in the precision, the movement, and everything. But then that can also affect the torque. Getting a bearing that is designed for your specific application is going to tremendously improve the product, because then you can talk about parameters and characteristics that you want this bearing to have, and then you can work one-on-one with another engineer to help refine your design.
How long should a self-lubricating bearing last?
Self-lubrication and life cycle and lifespan of the bushing has to do with life cycles. That ranges from robot to robot, and the main reason is because it depends what a cycle is. Depending on the manufacturer of the humanoid, one might have a different definition of what a cycle is compared to a different one. But realistically, I like to say that if this is something that's going to be put into a warehouse, is somewhere where it's routine, it's mundane tasks, I'd say anywhere from 2 to 5 years is what should be expected. And like I was saying, that really depends on what the manufacturer calls a cycle, how often the robot is employed, how long the robot is employed. But at the end of the day, it all comes down to cycle life.
What purpose do bearings serve in exoskeletons?
It's very similar to robotics. It has to do with any place that has some type of joint articulation. And exoskeletons, just like robotics, it's in the same locations, in the elbow locations, in the knee locations, shoulder locations, anything that has any type of articulation or articulating movement. It's especially important to imply this here, because in exoskeletons there is a weight that's bared upon on those joints, so you definitely want to have something in between so you don't have metal-on-metal contact.
And that's all for today. Thanks for joining us for 4 Questions with an Engineer.